5, 6, 7, 8. No. Please don't start dancing. I'm just trying to highlight the first few words that every dance student listens to. In fact, not just words, but numbers. What if I were to ask you, what is common between a dance period and a mathematics period? The answer is, it is the count. But this is only the beginning of the role of mathematics in dance. Today, I, Shreeyaa Popat, am going to present a lecture demonstration on understanding the mathematics in Kathak. When you watch a Kathak dancer perform, you observe the expressions and applaud at the spins. But when you listen to a Kathak dancer perform, you count the beats and feel the rhythm. The first lesson in Indian classical music and Kathak dance is to understand Laya and Taal, both through numbers. Laya is the speed or tempo, whereas Taal is a cycle of beats. And out of these two, it may be Taal, which you are less familiar with, so let's discuss that. A Taal is a cycle of a defined number of beats. It is a cycle, not a set, which means it plays on loop. Let's listen to a 16-beat Taal cycle called Teen Taal being played on the tabla and count together. 16. We come back to 1 to complete the 16th and last beat of the time cycle each time. This first beat is very crucial as it marks the beginning and end of each cycle of the Taal. The first beat of any Taal is known as Sam, which is a Hindi word. So, S-A-M in English. Every composition that a Kathak dancer performs to is calculated to fit in this Taal cycle. For example, ta thai ta ta thai, a thai ta ta thai, thai ta thai ta thai, thai thai ta ta ta, thai 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 ta ta ta, ta ta ta, ta ta ta, ta ta ta. Now that you know what Taal is, let's explore the various subjects that are common to Kathak and mathematics. Let's begin with the 4 basic operations of arithmetic, which are addition, subtraction, multiplication, and division. Suppose I want to compose a Thihai. A Thihai is a phrase repeated thrice to land on sum. For example, Tetikatagadiganadha, Tetikatagadiganadha, Tetikatagadiganadha. Suppose I assume 1 unit of this Thihai to be x. So the entire Thihai is 3x. This 3x should be equal to 16 plus 1 as it has to end on sum. So the formula can be 3x equals to n plus 1. What if this does not finish in one cycle of 16 beats? So I need to consider multiples of 16 such as 32, 48, 64, etc. So my final formula is 3x equals to n plus 1, where n stands for a multiple of 16. Let's explore an example of an 11-beat Thihai. So if I make a phrase of 11 beats, recite it thrice, the total is 11 threes are 33. And this fits in 2 cycles of 16 beats because 16 twos are 32, 32 plus 1, 33, which is the sum. Let me recite an example. Moving on to, you can even replace this phrase beats to 27 to get 81 on sum or 43 for 129 on sum. The examples are endless. Let's explore a longer kind of a composition which is known as a Fermishi Chakradar. In this, there is a mukhda as well as a Thihai embedded in it. And the entire phrase is repeated thrice, wherein the first x of the Thihai in round 1 should land on sum. The second X of the Thihai in round 2 should land on sum, and the third X of the Thihai in round 3 should land on sum, completing the composition. So the final formula is m plus 3x, the whole multiplied by 3, should be equal to n plus 1, where n is the multiple of 16. So let's try 81 as the value for the RHS. If you further solve this equation, substitute x for number 5, your Mukhra will be of 12 beats, Thihai will be of 15 beats. When you sum this up, it is a phrase of 27 beats. Multiplied by 3, 81. It will fit in 5 cycles of 16 beats because 16 5s are 80, 80 plus 1, 81, that's the sum. Let me recite an example. Chig tarang tatta tho tarang tak thun digdha dig thai ta thai ta thai ta thai digdha dig thai ta thai ta thai ta thai digdha dig thai ta thai ta thai ta thai chig tarang tatta tho tarang tak thun digdha dig thai ta thai ta thai ta thai digdha dig thai ta thai ta thai ta thai digdha dig thai ta thai ta thai ta thai chig tarang tatta tho tarang tak thun digdha dig thai ta thai ta thai ta thai digdha dig thai ta thai ta thai ta thai digdha dig thai ta thai ta thai. This brings me to my next subject, which is algebra and Kathak. I've often heard people say, what was the point of learning algebra in school? There's no value of variable x in the real world. Well, this is the value of variable x in the world of Kathak. Algebra involves the use of formulae to make our lives simpler. So now that I have a formula to make a Thihai or a Fermishi Chakradar, I can simply replace n with any other Taal, let's say 10 beats, 11 beats, 12 beats, etc. Here, I would like to mention that my guru, Nad Nritya Yogi, Acharya Pandit Anupam Raiji, has made a contribution in this direction of a list of formulae of how to compose Fermishi Chakradar compositions from each beat of the Taal cycle for a range of Taals, right from 5 beats to 32 beats time cycles. I would like to demonstrate a Fermishi Chakradar in 3 Taal.
Jig tarang tatta thu tarang tak thun tak thun digdha dig thai ta thai ta thai digdha dig thai ta thai ta thai digdha dig thai ta thai ta thai jig tarang tatta thu tarang tak thun digdha dig thai ta thai ta thai digdha dig thai ta thai ta thai digdha dig thai ta thai ta thai jig tarang tatta thu tarang tak thun digdha dig thai ta thai ta digdha dig thai ta thai digdha dig thai ta thai.
Moving on to the geometry in Kathak. When one dancer takes a spin, here, I'm essentially making a circle around myself. How many quadrants does a circle have? 4. I often teach my students to take a spotless chakkar. It is important to face the first quadrant and then complete the remaining 3/4 of the circle. If you start facing like this, it takes a little more effort to come back where you began. Similarly, in a chakkar where the dancer has to face 8 different directions. It's like dissecting a circle in 8 parts. So my foot has to face each of the 8 directions to take the chakkar spotlessly. Lastly, for a stage round where the dancer covers the entire stage, the dancer has to imagine a circumference which is essentially the entire stage. And the leading foot should always be along that imaginary circumference. The moment I step out of it, the circle looks geometrically off and less rehearsed. hand gestures, the basic hand movements one learns involves understanding of directions and angles. So for example, a hastak like this would resemble a 180-degree line in a circle. This hastak would resemble a V or a minus sector in a circle. This hastak would resemble a perpendicular in a 3D circle. Let's explore a Thai anga or a posture. Tadha. Guruji used to always teach me that in a posture like this, my right hand has to be parallel to the right leg. For that, I have to ensure that the shoulder to elbow is parallel to the hip socket and knee. The elbow to wrist is parallel to the knee and ankle, and the wrist to fingertips should be parallel to the ankle and toes, and my chin and eyesight in the line of my right hand. Let me demonstrate a nohakka to demonstrate the geometry of spins in Kathak.
Da din din da da, din da din din da din da, din din da, thei thei ta ta, gadi gana nagi tere kiti taka din da, krita gra nanda, tana da, gentara, kattara.
Moving on to permutations in Kathak. I remember answering this IQ test on a website which involved a pattern-oriented question. And I realized I was able to answer it because of my understanding of paltas in Kathak. Paltas are a series of permutated phrases of a main phrase. For example, let's explore a main phrase. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2. Now here, if I shift the position of 1, 2, 1, 2 from 5, 4, 3, 2, 1, then these are all the permutations that are possible. The slant that you see in the list of permutations is heard when a Kathak dancer presents it through the footwork. So these recited from the syllables would sound like takita 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 dhina dhina 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 takita 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 takita. I would like to demonstrate it with my footwork. Let's explore the subject of speed in Kathak through Laikari. I'm going to demonstrate a simple exercise. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1. Here, if you noticed, I did not alter the tempo of my clap. Just increase the tempo of my count. This is Laikari, where a basic Laikari would be 1, 2, 4 counts per clap. Can even do 3, 5, 7, 9 counts per clap. Can we do decimal numbers though? This is exactly what my Guru Nadritya Yogi Acharya Pandit Anupam Rai ji thought, and he contributed a list of all the Laikari that you see right from 1 to 8 and how to do it practically. But due to time constraints, I'll leave this for the next TED talk. To conclude, I will be sharing the similarities between Kathak and decimal system. You may be wondering if you're a genius that so far we've only discussed whole numbers for a Taal. But what if a Taal does not sum up to a whole number? Here, Guruji also contributed decimal tals. And thanks to his research today, we have a tal known as Sangam Tal, and I was a fortunate disciple to have learned it. Sangam Tal is of 8.75 beats. It has 3 parts. 1, 6 beats in speed x. Second, 3 beats in speed 2x, so the value is 3 by 2, 1.5. Third part of 5 beats in speed 4x, so 5 by 4, 1.25. And when you sum it all up, it comes to 8.75. And this is how we recite it. Fermishi Chakradar in a tal wherein the RHS has to be 8.75 or a multiple of 8.75. I would like to recite a Fermishi Chakradar in Sangam Tal and also demonstrate it practically to conclude my talk today.
Educator, Thhi, na 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 kat, ta, dha, tit, dha, da, tu na kat, tekita tekita thagi terikita terikita thagi det krana da da denikita thagi te tika 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 ne 1 2 3 4 1 2 3 4 1 2 3 4 tekita thagi terikita terikita thagi det krana da da denikita thagi te tika tika ne 1 2 3 4 1 2 3 4 1 2 3 4 tekita thagi terikita thagi det krana da da denikita thagi te tika tika ne 1 2 3 4 1 2 3 4 1 2 3 4.
All the things that I discussed so far are common to both instrumental music, vocal music, and Kathak. But the challenge in dance is to present it in an aesthetically pleasing manner. Hence, proved mathematics plays an integral role in Kathak. Thank you.